Okay, which of the following data sets or plots could have a regression line with a negative slope? Okay, so remember, a negative slope means as one variable increases, the other one decreases. Okay, so if x is going up, then y should be going down. That would be a negative slope, or it could be vice versa. X could be going down and y could be going up. Okay, so the number of hours you will be awake as a function of the number of cups of coffee you drink. So the number of hours you're awake, maybe A for awake, is a function of the number of cups of coffee you drink. So C is our domain variable. In other words, the amount of hours you're awake is A, which is the y variable, the dependent variable, and X is the number of cups of coffee. Okay, the independent variable. X should be causing y, right? Not the other way around. So just try to imagine what that scatter plot would look like. As coffee goes up, the number of hours you're awake should probably go up too, right? If you drink tons of coffee, you're probably awake a little bit more at night. Okay. So that's a positive correlation. We're supposed to identify the regression line with a negative slope, so we're not going to select that one. Because look, as you read this from left to right, the numbers are going up. So second part here, the number of hours you will sleep. So sleep as a function of the number of cups of coffee you will be drinking. Okay? And so this is the function notation. In other words, y is the number of hours you're sleeping, and x is the number of coffee cups. Okay, so let's graph what that scatter plot might look like. You know, if you drink tons of coffee, you're probably not going to be sleeping on the x-axis. So if you're somewhere in the middle, you've got your normal amount of sleep. And if you don't drink any coffee, this isn't a really super good example because it's not at some point you drink tons of coffee, you're still going to sleep, right? But this would be a roughly negative slope. The amount of money spent per day on coffee. So money spent per day on coffee as a function of the number of times you go to a coffee shop. So that's what it looks like in function notation. In other words, y is the money, and x is the number of times you go to a coffee shop. All right, so let me get rid of this. Give ourselves some room here. So try to imagine some data points. The number of times that you go to a coffee shop, as that number gets big, the amount of money you spend per day on coffee probably gets big. Whereas if x is close to 0, you're probably not spending a lot of money on coffee. And then the pattern keeps going. That's a positive slope. As you read it from left to right, it's increasing. So we're looking for negative slope. So the last one, the number of minutes you will wait to pick up your coffee. So that's our x variable. No, sorry, that's our y variable. As a function of the number of people who are working behind the coffee shop counter. So number of people working. If there's a lot, the wait time is probably small, right? And if there's just a medium amount of people, then the wait time is probably typical. And if there's only one person working, the wait time is probably pretty high. So that's a negative slope.